Hello everyone, welcome to the first video of complete course on Python. This course is created by Crowd Course Initiative. In this video, we will cover the absolute essentials of Python, namely numbers and how to perform calculations on them. You will learn different numeric types which Python supports and common operators including addition, subtraction, multiplication, and division. Python is a language that is used extensively in numerical calculations and subjects related to mathematics. Due to this fact, understanding how to use numbers is critical in learning Python as a programming language. The first thing that you need to know is that in Python, numbers can take different forms. There are four types of numbers you can have, namely integers. Integers are nothing but numbers without decimal points. The second kind are floating point numbers. These are nothing but numbers with decimal points in them. The third kind are complex numbers. You will encounter them more in scenarios including video game development, etc. So it will not be discussed here in detail. The fourth kind are long integers. Long integers are also not usually used. They are more storage heavy compared to integers and they can have infinite precision. However, integers and long floating point numbers are more prevalent. So we are going to cover a lot about them in this video. Now that we have discussed about numbers, let's see what we can do with them. Consider numbers as building blocks. Then several complex equations can be formed using numbers and operators. Operators can be generally categorized into two types, binary and unary. Binary operators are the operators which operate between two numbers, and unary means it has effect on only a single number. Here are some of the examples of binary and unary operators. Binary having addition, subtraction, multiplication, division, remainder, and exponential. Unary operators supported by Python are positive and negative. Addition, subtraction, and multiplication in Python is very similar to what we usually encounter in math. But here are 2 points worth mentioning. In Python, when you add two integers, you get an integer back. Same for subtraction and multiplication. But however, if one of the operands is a floating point number, Python will automatically give you a floating point number back. Division works a little bit different, which we'll explain in the next section. From the second operation in multiplication, you can see that the unary operator takes precedence over the binary operator. We can see that under most circumstances, the unary operator takes precedence over binary operator. However, putting a parenthesis or bracket is always a good idea when you're in doubt. Now let's look at division. As you can see from the table above, different versions of Python handle division differently. In Python 2, dividing an integer number by another integer will return the quotient, omitting the remainder. However, in Python 3, dividing two integers will return a floating point value even without specifying for it. In order to get solely the quotient, as in Python 2, you need to put two division operators together, as you can see in this example. The remainder operation in two different versions are the same. So always keep an eye on what version of Python you're using. Now we are going to talk about exponential and power operations. While the multiplication operation requires only one asterisk, the exponential operator requires two. Similar to multiplication and division, raising an integer to an integer power gives an integer value back. But the presence of at least one floating point operand will force Python to output the result as a floating point number. Let us look at a few examples to figure these one out. Let us now see how we achieve 2 raised to power 3. We do this by using the exponential operator on the operands 2 and 3. Now let's look how to find out square root of 4. As in mathematics, square root of 4 is nothing but 4 raised to the power half. To do this, we just simply write 4 followed by the exponential operator and then 0.5. Now if we have to do inverse exponentials, we just provide the second operand as a negative integer. Let us look at this last example more closely. As you can see, it is not a mathematical operator. It is a Python function provided by the language. In Python, we can use these mathematical functions giving appropriate arguments to get the required results. For example, here, the function POW takes two arguments. The first one is the base, and the second one is the exponent. Python actually offers a bunch of these functions to make our lives easier when we try to play with numbers. Python also has built-in functions for calculating the absolute value of a number, which is also the positive value of the number. So let us look at a few examples. ABS is a function provided by Python which takes in an integer and which returns the positive value of the number. For example, absolute value of -7 is returned as 7. Python also has a rounding function for you. You can use the round function to pass a floating number and to round it up to the nearest integer. The round function in Python uses the same rounding rules used in mathematics as well. It is also known as the half-adjusting rule. It is designed in a way to make your transition from mathematics to Python easier. You can utilize the round function in a more complex way by providing the precision to which you can round. Now that we've looked at numbers, let's look at another simple data type which is called a Boolean. Booleans are nothing but constant which are used for evaluating truth of a statement. There are only two Boolean constants, true and false. You must notice that the first alphabet of the constants is capitalized, which is different from most of the languages we know. Let us evaluate a couple of statements to see how this Boolean works. So let us evaluate 1 plus 1 double equal to 2. This statement basically evaluates if 1 plus 1 is equal to 2 or not. By evaluating this, we see that Python interpreter outputs the value as true. Let's evaluate another statement. Let's check if 1 multiplied 0 times is equal to 1 or not. This returns false. Now that we have covered Booleans, let us see what kind of operations you can do with Booleans. They're basically three Boolean operators: and, or, and not. Let us understand these operations by using a few examples. The first example evaluates if 1 equal to 2 or 1 equal to 1. Let us dive deep into this equation to see what happens internally. The first part of code evaluates if 1 is equal to 2 or not. So this basically evaluates to false. So this is basically false or 1 equal to 1. 1 equal to 1 evaluates to true. So basically the whole statement is equal to false or true. Because or is same as our mathematical or, and existence of a true, it makes the whole statement to be evaluated as true. The output of this will be true. Let us take a look at another example. This example evaluates if 1 equal to 1 and not of 1 equal to 2. Let us see how this equation evaluates. The first part is to check whether 1 is equal to 1. So this basically evaluates to true. And then in the second part, it evaluates whether 1 is equal to 2. This part evaluates to false. But since it has a not before it, it is the converse of that. So even though 1 equal to 2 evaluates to false, a not before it makes the statement true. So true and true evaluates to true. With that, we come to the end of this chapter. Hope you enjoyed it. Thank you.